Polynomial functions in factored form. Okay, my job during this lesson is to convince you that if the functions are in factored form, our life is wonderful. Graphing it will be very straightforward, no matter what degree it is. Degree 3, degree 4, degree 5, don't care. Any degree will be fine, as long as it's factored. And by the end of the lesson, you're like, yes, but what if it's not factored? Don't worry. Big lessons coming on factoring. Yeah, lots of stuff coming on factoring. And I think the procedure will make it that your life will be easier for factoring. It'll take long. It'll take a while. But it'll be easier than what you had to remember for factoring before. So don't let factoring become a bad word just yet until you see what I have to tell you. But back to today. Today is, if it's in factored form, life is wonderful. My job to convince you that's true. Warm up. For each of the following, state the zeros in the end behavior. Okay. On the off chance you didn't get to that homework for last time, we got to review this. We got to know this stuff going in. Find the zeros and the end behavior. This is actually the first question in the homework when you go to this homework. This is exactly just like this. Okay, let's talk about zeros for a second. There's something that was supposed to be clear in grade 10 about zeros. That finding zeros was easy if you were in factored form. Those two things lock right together. You're like, how do I find zeros? How do I factor? Those things are married together. If it's factored, finding the zeros is easy. You take a look at this and you go, I want to know what's going to make this function come out to 0 over here on the left-hand side. And you go, what x values will make it 0? Not easy to do. In fact, you saw the one yesterday, the quadratic formula one. Finding zeros is not easy sometimes, and you got to use the quadratic formula to find those zeros. He said giving away a question on the test. Yeah? Sometimes when you want to find the zeros, you got to use the quadratic formula. But if it's in factored form, it's so easy. It's the easiest thing ever. I could explain this probably to my 7-year-old. What number will make this set of brackets equal to 0? -7 will make that bracket equal to 0. That will mean that this is 0, and then it multiplies by everything else, and everything becomes 0. That's why factoring is so powerful. If we get it factored, we can find zeros easily. Then there's this one. What number makes this bracket 0? -4 makes that bracket 0. What number makes this bracket 0? 5. Do you sort of remember this from quadratics? You've broken into two pieces, and then you solve the two pieces. So the idea being right now, and you got to tell me right away if it's a problem, is that when you have it in factored form, you should be able to just read off the zeros. It'll be all the opposite numbers. There's one more slightly difficult situation, which I'll talk about in a minute. But for now, let's just assume we can just look at them and go, oh, when do they 0? All the opposite numbers will make this thing 0. Now, end behavior. Well, okay, end behavior is a problem. See, it goes ahead and says it knows what the function is and the leading coefficient is. And maybe that's not obvious until you see me do this once. Sorry, I'm just going to fast forward a little bit to see where I've got space. I don't have space there. So I'm going to do this on a separate page over here. Oh, I want to do this here. Actually, I'll do both of them. There we go. Now, I'm hoping that this side work I'm going to do, by the time I finish it, you'll be like, oh, I don't need to do that side work anymore. I can see what's going to happen with these things. It's not obvious what degree this thing would be. Maybe. Maybe some of you are like, oh, I know what degree it would be. But maybe you got to see it once to see what degree would come out of this. If you wanted to take this from factored form back to non-factored form, check out all the work you got to do. It's crazy. Watch. Okay, so you go equals, and I go FOIL this set of brackets. So x squared plus 4x, and then FOIL this set of brackets. But I haven't dealt with this set of brackets at all yet. Then collect. Now, strap yourself in for what's going to happen next. Watch this here. So all I did was FOIL out that first set of brackets. Okay? First, outside, inside, last. Remember FOIL? FOIL's good. Okay. Now check this one out, though. This one now 3 terms by 2 terms. There's a very good chance you haven't even done one like that before. You got to go x squared times x cubed. X squared times -5, -5x squared. 11x times x is 11x squared. 11x times negative 5, negative 55x. 28 times x, 28x. Minus 140. Right? Now we collect all the like terms. How did I do? Negative 5 plus 11 is positive 6. Negative 55 plus 28, negative 27, minus 140. Crazy stuff, though. You know, I did it in a couple of lines. I've done a million of them, so no big deal. Now, you did all that work to come up with all this information. Let's rewind back to yesterday's lesson. If we want to know end behavior, there's two things we want to know. We want to know the degree, and we want to know the leading coefficient. It's all right here. So I did all that work just to come up with the first term. When you want to know end behavior, you don't have to do all that work. You just have to look and go, well, okay, x, x, x. Those three leading things, just multiply them together to get this. Okay? So the opening homework question asks for something like this, but you can look right at it and go, okay, when I multiply these brackets together, what am I going to get? I'm going to get x times x, I'm going to get x squared as the first term there. Then still got to multiply by this x here, and I get x cubed. And forget all the other work. There's almost never any real time in math, actually, where we want to go from this form back to this form. We almost always want the factored form. So I suggest in questions like this, you don't do it. You just go, okay, what would I get out of this whole situation? Back to the PowerPoint. The function is cubic. I can look at it and go, okay, I've got an x and an x and an x is going to come out to x cubed if I was to multiply it out. I'm not going to, but if I did, that leading coefficient would be 1 because x times x times x is x cubed. End behavior now. Okay, this is yesterday's lesson. Degree 3, leading coefficient 1. If it's degree 3, it's odd. What are my choices here for end behavior if it's odd? Good, yeah? Like this or like this. Either it's going to be opposite on either side. Now, if it's a positive coefficient, then you got to have your brain on to go, is this one the positive one? Or is this one the positive one? And I always go to positive x values. For positive x values, with a leading coefficient of 1, I must have positive y values. That means it's this way. Okay, and that's where they get this. And if that doesn't come quite that fast, as what I just said it, I really tried to slow it down. So I'm not trying to be insulting. I'm just trying to say, yeah, maybe it's possible you got to do the end behavior homework before that is going to come quickly. You got to walk through it slowly like I did there. Let's try another one. Look at this mess. Zeros, no problem, because it's in factored form. Zeros we get from, I'm going to switch over to highlighter here. We got x plus 3, so we know one of the zeros is negative 3. We got x minus 2, so we know one of the zeros is positive 2. Those are the numbers that would make these equal to 0. But this is the one I was talking about. A little bit troublesome there, 2x minus 5. Some people can do them in their head. They just go, okay, yeah, 2x minus 5. I know when that's equal to 0. But if you can't, you just do a little work here. Let me show off the work here. You just take this thing and go, okay, well, I want to know when 2x minus 5 is equal to 0. So I just got to solve this little equation. Jeez, did you see that? Wow. Just do a little work there, if you have to. Some people can look right at them and know, but if you have to do a little work, then that's fine. So the zeros out of here are negative 3 from this bracket, 2 from this bracket, and 5 halves from this bracket. This messes people up, this leading coefficient sometimes, because they go, well, wouldn't positive 2 also work here for this one? Well, positive 2 does work because of this here, but an x value of positive 2 doesn't make negative 2 0. It makes x minus 2 0. So this part we care about, but that part we don't. The function is quartic. Oh, how do we know it's going to be quartic? We get an x, multiply it with another x, multiply it with a 2x, but then multiply it with 2x again. So you get actually degree 4 here. This thing actually has 4. Leading coefficient is negative 8. Negative 2 times x would be negative 2x, times x would be, I'll write that in there, so now we're at negative 2x, times the x would be negative 2x squared, times 2x would be negative 4x squared, times negative 2x again, that's how they get the negative 8x. Okay, so I'm just multiplying that opening term. Otherwise, you're stuck with multiplying the whole thing out. But I think just multiplying the opening term. And actually, the fact that it's negative 8, we don't even really care that it's negative 8. We only care that it's negative. Okay? So now, degree 4, negative power. If it's degree 4, hopefully your brain's doing the dance here. Good, I'm seeing a couple people doing it. If you're doing this, you're in great shape. And if you're doing this, you're in perfect shape, right? Because negative, degree 4 would be up like this, negative would be down like that. So here's the end behavior as x goes to infinity. You go to negative infinity as x goes to negative infinity. You go to negative infinity both sides. Yeah? That's really a review of yesterday's last lesson that we did. But do you have any questions about all this? All right. Take a look at these functions that are in factored form. What I really want to show you about is not the zeros, because we just talked about the zeros. What I really want to show you is I took this function right here and I graphed it on Desmos, and I brought the graphs in here for you to look at. Notice that x plus 2 squared has a 0 at negative 2. So let me just draw an arrow there to show where these zeros pop in. Incidentally, when you first see this, I'm not saying you should be able to graph this right now. What I'm saying is, after you see me graph these, you might go, oh, now I've got a chance at graphing those. Ink color, red. Okay, so right there. That becomes that 0, and that becomes that 0. That's not the important part just yet. I just want to talk about zeros for now. Now look here. What x value will make this 0? Negative 2, so there it is, the 0 on the graph. That one will be a 1, and that one will be a 3. See? And then this one, negative 2, and this one, 1.5. You may have to do that separate work to get that one. So you just get those right from there. Now, there's something else going on here. This is the key point of the lesson. If everything else is like, oh, trying to get my brain clear, trying to get focused, now this is what you want to hear about. It's not really a big deal. It's not that hard. This factor was squared. This factor was squared, and both of these factors were squared. Something happens when you get a squared factor. We don't really explain why it happens yet. We need calculus to do that. I keep mentioning calculus and trying to do a sales pitch for how awesome calculus is. For now, we just look at it and see what's happening. You see, when you have a regular 0 like this, see, the function just goes right through the graph like that. Let me get to my laser pointer and really show that. Laser pointer, there we go. See, when we have a regular 0, the function just goes right on through the axis like that. When you get a 0 here, it just goes right on through the axis. This one, right on through the axis. This one never happens. What happens when you get I call them double zeros, because they got a squared there. It really does describe what's going on. But if you get a power of 2 on there, what happens at that 0? It's also a turning point. Like, okay, so far, this lesson, what I got to know is squared means turn. Yeah, absolutely. That's the big moment of this lesson, is that squared means turn. It's down here. The zeros corresponding to squared factors are also turning point. The graph has sort of a parabolic shape there. It sort of looks like a parabola right in that little section there. The x-axis is tangent to the curve at those points. See, the tangent, it levels out. Same as saying it's a turning point. That gets the highlighter. The yellow highlighter. Zeros corresponding to squared factors are also turning points. The rest is a better description of what's going on there, but that sentence really covers it. Any questions about that? Let's do the same thing with cubed factors. And I want to go through all the zeros things again, just in case the 0 thing isn't. At x minus 1 becomes a 0 at 1 right there. X plus 4 becomes a 0 at negative 4 right there. X minus 3 becomes a 0 at positive 3. X plus 2 becomes a 0 at negative 2. And take a look at this one. Oh, okay, I'm going to get out the big red pen here. Pen. You can't see that very well, can you? What color is going to be better? How about green? Can you see that good? See that X in there? It results in an x-intercept of 0. Almost always missed on the Unit 3 test. You know, that's 0 there, so I make a big point about that. Okay, so all zeros there. So those are the same before. There's x equals 1. There's that 0 there. There's x equals 5. There's that 0 there. That's really not what we're supposed to be talking about in this lesson. I only mention it because of, you know, where we've come from and everything that's happened to us in this journey. Now, in each one of these, there's cubed factors. What happens at the cubed factor? What weird thing sort of happens here? It's not a turning point. It's a 0. For sure it's a 0. But it doesn't go straight through like this one does. It sort of levels out there. My word, I use the word bend. It bends at the axis. And again, it's not clear why that's happening. But for now, in this course, we just notice that it is happening. Cubic, we get a bend. Cubic factor, see how it bends at the axis? And this one you can definitely see the cubic factor. But look at this one. That's got the bounce. Actually, those are the two words I use when people are first learning about this. Squared factors, bounce. Cubed factors, bend. See what happens with regular zeros? You just go straight on through. You just keep going right on through. And these graphs show it perfectly. Are you ever confused about this? You just look back at these graphs because they show exactly what's going on. Let's review the whole lesson right now so that you're clear on what you're supposed to know by this point in the lesson. 1, if you want to get that leading coefficient, just look at the leading terms, multiply them together, and you'll get your leading coefficient. 2, squared factors, bounce. Cubed factors, bend. It uses a sentence. The graph, it resembles the graph of y-axis cubed at the cubed factors. We're not going to really see the graph of y equals x cubed. For now, the bend is the better word. But the next lesson talks about x cubed, and that really helps to have some more words here. Any questions there? I'm going to do some examples. I'm going to do some ones like right from the beginning. Let's try and do this whole thing, because this was sort of the reverse. We give you the graph and say what's going on. We got to be able to do the other question is, here's the equation. What's the graph? Oh, here they are. Oh, beautiful. Perfect timing. 3 examples. This is what you got to be able to do. So if you don't have this note in front of you, you definitely want to get a sheet of paper and copy these down, because this is the stuff you got to really know how to do. Keep all that stuff for now. And switch over to here. And there. Good. I've brought over 1A, and I've got myself a piece of graph paper here to graph. If you don't have graph paper, actually for the graphs I'm about to do here, you could probably get away without graph paper. But best if you do these examples on graph paper, separate sheet. Okay, here's the work. So if all that stuff was sort of muddling in your brain, you're like, I think I sort of get what you're saying, but I don't know if I could do it. Here's the steps to graphing this thing. This will be true all the way through chapter 3. This is how we graph these things. The only thing we'll be missing is we'll have to be able to factor them. These are in nicely factored form. Okay, here are the steps. Here we go. First, find the zeros. And your job then is to list the x values that will make this function come out to be 0. So actually sub to 0 in there. That helps people sometimes. Say, I want to know when this function will be 0. So you have to imagine what x values will make this 0. What x value makes x plus 1 equal to 0? Negative 1. So here are the zeros. X equals negative 1. What x value makes x plus 3 0? Negative 3. And what x value makes x minus 2 0? 2. If you're noticing something about the 2, good. That means you understood the lesson. If you didn't notice something about the 2, don't worry about it. I'm going to pretend I didn't notice it either, make a mistake, and we'll see what happens when I make that mistake. Next, some people get confused about this negative 0.5. It doesn't have any effect on the zeros. It doesn't do anything with the zeros. I'm going to show a demo of that a little bit later. But you just can't, there's no x value I can put in that changes this to 0. There's an x value I can put in that changes this to 0 because I have an x value to put in there. Only spots with a variable can you worry about. Now, actually, this is a ton of information. This is an unbelievable amount of information about the graph. Let me just graph those. X equals -1, x equals -3, and x equals 2. And just like chapter 1 where I gave you 3 points to start the question, we're in great shape here as far as the graph's concerned. It's either going to do like this, or it's going to come up and go like this. You know, I sort of have an image in my mind of what this thing has got to look like already, and all I got is 3 zeros. That's why factoring is so important, because I can get the zeros, and then I'm on my way to having the graph. The next move is to get this leading coefficient. And as I do that work, I'll easily come up with a degree. So all I do is, I'm going to switch to a different pen here, is I just sort of look at what's going to happen with the leading here. Negative 0.5 times the x, and then times the x twice, because there's 2 of those there, right? So you got to watch out for those squared factors a little bit. So I'm going to get negative 0.5 x to the power of 4. Do not let me get away with carrying on unless you really understood how I did that, because that's, I think, the only difficult part of the lesson. Everything else is just do I remember all the pieces that have to go together here. In my mind, I went negative 0.5 times the x, times this x, and times this x twice because there was x squared. Basically, I was doing all this. I did instead of going through all the steps, I went, oh, I only want the first one. So I'm not going to go through all those steps. I'm only going to do the leading ones every single time to find out what that leading term would be. It would be negative 0.5 x to the 4th. Apparently, that's enough to get end behavior. And if you haven't done this homework yet, well, you're going to be extra ready now because we're reviewing it right now. End behavior. X to the 4th. There's something you're supposed to know about x to the 4th, power 4, and end behavior. Same both sides. Now, with a negative out front, that means down both ways. So your brain's thinking this, and you're writing this. X goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to negative infinity. Same both sides. Down both ways. Now, I'm going to get my green pen out and make a mistake. Don't copy this part because something bad's going to happen here, okay? Because I've missed something. Maybe you already know what it is, but I've missed it. It's the whole point of this lesson. This stuff that's yesterday's lesson. This is really grade 10 stuff, finding zeros. End behaviors, that's chapter 1. None of that's new. I'm just tying it all together. Here's the new part of this lesson, coming right up. Okay, so it's got to start down here. This is not the mistake. It's going to go through this 0. It's going to go through this 0. Then it's going to go through this 0. And it doesn't end up down both ways. Mr. Todd's wrong. Math is broken. What did I miss? And it's the whole point of today's lesson. Have to turn at the 2. Yeah? This is also a turning point. So let me just get rid of all that. And watch how nice this plays out when I get it right. I don't know how you want to handle this. Maybe you want to circle it right there and say turning point as you're doing these questions. Maybe you want to hand out at the end. Maybe you want to do it right at the start. As soon as you see the squared factor, you're like, whoa, whoa, whoa. Before I even get going here, I know that's got to be a turning point. Well, watch how that changes everything as I go through here. Turn at the 2, yes? Turn at the 2. Through that 0. Through that 0. Let's just pause for a second. You should be shocked and amazed at how little work it takes to come up with an unbelievable graph of a degree 4 function that's really pretty complicated. It doesn't take much. You get the zeros, you get the end behavior, you watch for bounces, and you get a beautiful graph. There's one little difficulty. How do we know how high or low to go here? We don't. We're going to circle right back to these type of problems in chapter 3 of calculus when we can find these max and mins perfectly easily. Yeah? So for now, we can only do shape and advanced functions. The calculus people have to fill in these gaps here for us. But still pretty good. We know sort of where the max is. We could sort of estimate where it is. Is that -2? Looks like, is that 0? We could plug in 0 and find this y-intercept if we wanted. You know, pretty good result. What questions do you have? Do you need more time on that one? The turning point. Because it was a squared factor, we found out that any squared factors are a bounce. They're a turning point. So as I was doing the end behavior here, as I came up here and I got to the 2, instead of going straight through, which messed up the other graph, I bounce off that one. The other factors, I go straight through. Does that help? Yeah. And it's a great question because it's the whole point of this lesson. Everything else I've grabbed from other points of high school math. The degree 4? So when I'm going to ignore the -0.5 for just a second. If I were to multiply all these brackets out, I'd go x times x, and there'd be this x squared term. And there'd be some other terms, but x squared would be the highest degree term. Then I'd take that x squared term and I'd multiply it by this x term. I get x cubed. And then, because it's squared, there'd be another one, and then I get an x to the 4th. And to see all that, I did that all here once to go, I multiplied the whole thing out. And the point I was trying to make was, when you multiply the whole thing out, these are complicated. This 6x squared -20, it's really hard to get all those terms. But the leading term's not that difficult to get because you just take the leading term from each bracket and multiply it through to find out what we're going to end up here. It also works for the leading coefficient. The leading coefficient is -0.5 times x times x times x, and I end up with the -0.5. If there was other numbers in there, I'd multiply them as I went. But does that help? Yeah. Great question. In fact, those are the 2 questions at the end of this example that's really new today. The only 2 new things I've taught is, how do I get this leading coefficient? And watch out for bounces. I'm going to do a couple more that just do some more stuff there. Okay? So we'll do another one. Ready? This example can make your brain explode. This might be what's going through your mind when you see x to the 4th plus 2x cubed. You're like, Mr. Todd, that's not factored. You sort of implied at the start of this lesson that this lesson was polynomials in factored form, that I wouldn't have to factor here. That you're going to teach me factoring later in the chapter. You can see on the board over there. Factoring. Look at the names of the lessons. Factoring. This is actually a factoring assignment. Factoring. Like, we're almost done to the point where we're just going to go, now we got to learn how to factor if we're going to be able to do these. So in the middle of this, you're like, I thought you were going to teach us factoring later. I am. But there is one type of factoring you do actually know how to do for degree 3s and for degree 4s. What type of factoring do you see here? Common factoring. It's why we beat it to death. I promise it's going to come back and haunt you. And it will. It'll keep coming and keep coming. Common factoring is the one you got to watch out for all the time. Here's the common factor. Both of these have an x cubed in them. So I can factor out the x cubed. What I'm left with when I take out x cubed, the first term now has an x, and the second term just has the number 2. And now it's in factored form. So if I did promise they'd all be factored today, I lied. What I will say is about this lesson is the only factoring you have to do is common factoring today. Now I'm ready to do this question. First, zeros. I switched over to the color green here. I kind of like it. Very Christmassy for December the 1st. Zeros. We want to know when this thing comes out to be 0. Let's do this. Let's do the bracket first. It's actually the harder thing to do, but we'll find it easier because we've done more like that. What number will make x plus 2 equal to 0? -2. I phrased it that way, even though you might be like, I don't need all those. That was the longer sentence that I needed. I can just look at it and see. But I phrased it that way on purpose to help you for weird situations. What number will make x cubed equal to 0? just x equals 0. So watch out for that. It's often missed because it's so simple almost. It's so simple it's hard because you're used to these more difficult situations where you have the brackets. And I argue again that this gives me an unbelievable start on the graph, just having those zeros. I like graphing them immediately. As soon as I get zeros, I put them on the graph. I'm not going to change those. I just know something weird is about to happen here, so I want to get ready for it. All I'm going to do is take this grid I've got here and just zoom it up a little bit because we're going to need to be able to see pretty good. On your piece of paper, you're probably okay, but on mine, I just want to make sure I've got space to show something here. Next, end behavior. Well, no. The two things we need for end behavior. On the off chance you haven't finished yesterday's homework, I want to teach this carefully. We want the degree and the leading coefficient. And from that, I can get the end behavior. That's yesterday's lesson. Here comes yesterday's lesson in a nutshell. I can feel you out there going, well, you know what? If I understand this, maybe I don't have to do all that homework. If you have time, you should really do it all. But you're right. If you totally get this, going back to yesterday's end behavior and zeros homework should go pretty quick. There's bad news when things aren't factored is you got to factor them. The good news is finding the leading coefficient in the end behavior is really easy. You don't have to go through all that stuff I just showed there. You just look and go, okay, leading coefficient 1, degree 4. Do your little dance. X to the power 4. Both up. Leading coefficient positive, so it stays up like this. Your brain for end behavior is thinking this, up on both sides. End behavior, so it's just write it as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to infinity. And I'm going to make the same mistake I did in the other one. Okay? The exact same mistake I'm going to forget to do what today's lesson's all about. I'm going to switch over to red. And behavior, both up, like this, right? So I start up, I go through the 0, I go through this 0, and I end up like that. That's simple. It is. It is almost that simple. But I missed one little thing. What's the little thing I missed? Say it again? Yeah. This 0 here is a bend. That's my word. You won't see that word in the textbook. It's just the best word I can think of to help you when you're first learning this, is that I had to bend when I got there. So let me erase all that. Is it going to let me erase it nicely? No, not really. Okay, so go back, put those two zeros on. And putting bends on is not always easy. I'm there for you on your test. If you sort of show it bending, I'll be looking for it. Did they make it bend? Oh yeah, I can see the little bend there. So don't get too bent out of shape with this. Here comes the graph in red. Bend at 0. The best way I can tell you to bend is get low if you want to be able to bend. So you get low and you bend through there. Can you see the difference between the bend and the not bend? If I can see the difference between the bend and the not bend, I'm going to give it to you. Yeah? So don't get freaked out that you have trouble showing it. You see that's a massively different graph than the other one? This bend really shows that flattening, like maybe coronaviruses add that word to our vocabulary. The flattening of the curve here. There's definitely going to be a flat spot coming out of here before it heads off to infinity, which is a really big difference. Any questions there? The end behavior says, as you go out to the ends, we should go out to the positives. The end behavior doesn't comment on what's going to happen between. If you want Like the end behavior is the perfect word if you really think about it. We've been using it as a catchphrase, end behavior, but it's really a very good description of what part of the graph we're talking about. Just the ends, just out here. So when we talk about end behavior, I'm going to highlight what we've learned. That's all we've learned, actually. The stuff in between, we're going to have to fill in with zeros and with factoring and all that stuff that we're going to work on. When we finish the end behavior lesson, that's all we've got. I mean, I stand up here like this, and my arms in the air like this, and it implies that I know a lot about the graph. I don't. You know, I'm going to change that now and just sort of flash my hands like this. This is all I really know, is where it's going to end up. And that end word is really good. Yeah? Did that help? Yeah. Okay. More questions? What's next? 2, write the equation. Oh, completely different question. Uses the same thinking, but actually goes the complete opposite way. Doesn't ask for the graph at all. It says, write the equation of a cubic function. Okay, here I go. I'm ready. Write the equation. I got y equals. I know they want me to write the equation. Y equals. The cubic function has zeros at -2, 3, and 2/5. If I know there's a zero of -2, I know one of the factors. What's one of the factors if it has to have a zero of -2? Tell me more about it. X plus 2. He said 2, and I think he knew exactly what he was talking about. I think he would have wrote the right thing, but I just needed a little more from him to get the first factor. Having done this question 100 million times before, I've cleverly left a space in front of x plus 2, and I'm trying to plant that in your brain to think about something else that has to happen here. All right? We'll get to that at the end. If it has a 0 at x equals 3, can someone tell me another factor that's going to have to be in this thing? X minus 3. Oh, this one's tougher. 2/5. You really got to think this through. He suggests 2x minus 5. Here's what I suggest. I don't know if I haven't thought about it carefully enough myself to know if 2x minus 5 is right. My suggestion when you run into one like this is just to write it off on the side and go 2x minus 5. I think it's 2x minus 5. Let me check if this works. 2x minus 5 equals 0. 2x equals 5. That will give an x of 5/2. It's not right. And that's exactly how I handle them. I just, in my brain, I go, okay, could it be this? I know it's a 2 and a 5 one way around. I try it and I go, oh, that's not right. So it's got to be the other one, which is this one. 5x minus 2. That'll give, when I move that over, 2 divided by 5. So yeah, it's sort of like a little trial and error thing. A few check marks here. I got that, I got that, I got that. Good. And has a y-intercept of 6. Does this have a y-intercept of 6? If I put x equals 0 in here, that would be a 2. That's -3. That's -2. Let's just check this out. Does it work? Y equals 0 plus 2, 0 minus 3, 0 minus 2. If I multiply those all together, I get 6. I get 12. The function I've created has a y-intercept of 12, not of 6. Uh-oh. And if you know what to put out there to fix it, it's fine to know how to fix it. And that might bail you out on a test, actually. Might. Here's the method that handles it so that I don't have to just figure it out. We know what the factors are. From those zeros, we know what the factors are, but maybe we don't know what the common factor leading coefficient is. We almost always call it the A value. Sometimes the homework calls it the K value. Could be that there's some number out there. Maybe it's a 2 or a 7 or a 5 or a -3. I don't know. So I just put A in there for the, and I do what we did with the y equals mx plus b yesterday, sub in 0, 6. I need it to come out so that 0, 6 works. So I put a 6 in here. And if your brain's freaking out, don't. This sub is the perfect sub ever. It's even better than the sweet onion chicken teriyaki sub. Have you had that one? It's good, right? It's good. This is a better sub than that. Because subbing in, it looks like, what? Look at this giant mess. And then you sub in, you're like, oh, wait, it's okay. No panic. It's not really a big problem here. Over here I get 2 and a -3 and a negative 2. It's really not that bad, all right? Is it about to get bad with subbing? Oh, yeah. Yeah. Lots of great subbing coming. This is like introduction to subbing. You know, you're just sticking our toe in the water like, oh, it's not so bad. A little bit of subbing, not a big deal, yeah? Because over here, let me do all this work over here. 2 times negative 3 is negative 6 times negative 2 is 12, and then a little dividing. So no freaking out, okay, folks? Like so far, subbing, not too bad. A is 1/2. Therefore, y equals 1/2 x plus 2, x minus 3, 5x minus 2. There's the equation. I can now check that part off as well. The good news is lots of part marks available on a question like this. If you can at least do the factors, you can get most of the marks. Then the subbing finishes it off for the rest of the marks. Definitely some great practice questions of those in the homework, on the review, and on the practice test for the Unit 3 test, which is looming in the back of our mind. Any questions about that big mess? Let's do another one like that, just to make sure we get that really down pat. Do you need more time? I wrote really quick at the end there. What was the result? Did anyone go to Staples last night? Anyone got a calculator to show off? Maybe I'm going to Staples tonight now. I want a version 2. Got the iPhone, got the watch, need the calculator, right? More time here? Another one sort of like that. Except with a graph instead. Let me make this graph a little bigger. For the given graph, write the equation, the function, status, domain, and range. A couple people have learned a lesson about questions that ask more than one thing on tests. Maybe when you first get this, you're like, okay, I'm going to find the equation, but before I forget, let me just write down the domain and range. Little domain and range off to the side there. Done? Okay, now I can work at the equation. For this lesson, what's the most important points on this to help me get the equation? The zeros, yeah. Big dots there. When you're graphing, put big dots for the zeros. They're very important. When you're given a graph, put those big zeros in there because it really helps to come up with the factors. If it goes through a 0 of negative 2, what factor has to be there? X plus 2, yeah. Look what I've done for you here again. Trying to give a hint. I've left that space out there going, there might be a number out there. Get ready. I might have to solve for that number out there using a little magic subbing. And then if it goes through a 0 of 3, what factor also must be there? Negative 3. And it's got to go through this point, 2, 4. So yeah, I'm going to have to solve for some kind of a value. However, this question has just a little bit more to it. It's not a big deal. What do you notice about those zeros? They're also turning points. Sort of the turning point of the lesson here. Yes? It'll really change everything if you forget that. Yeah? You still get most of the part marks though. You know, like so if it's the type of error that after the test you're like, oh, did you get those squared zeros in number 7? You're like, no, I didn't. But it's not going to take your mark at something you fail or something like that. If you do all the subs and everything like that, you're still going to get most of the marks. So then how am I going to find this a value? Ooh, I'm not going to write it. Let you think about it for a second. How am I going to solve for that a value? Sub in. Yeah? Subbing is going to be your go-to move for a while here now. question, you're like, oh, well, how am I supposed to know? How am I supposed to make that work? It's going to be a sub. Sub in 2, 4. And again, in this chapter, it may look like a big, hairy, scary mess, but when you sub in 2, 4, life will get good really fast. 4 equals a 2 plus 2 squared, 2 minus 3 squared. You see why it suddenly just simplifies completely? The x and the y's are all gone now. It's all just numbers. The rest of it's just like bed mass, you know, like working these things out. So 4 equals 2 plus 2 is, oh, show all the steps. 4 squared, negative 1 squared. Take a look at those steps and see what your questions are. Staples?
I don't know.
Must be. Oh, it is. Office supplies. Who said it yesterday? I love Staples. Yeah, I ordered a bunch of stuff from. It's called eWay when you order it online through a business, you know. But anyways, hey, there, some excitement for me this afternoon. Tell me, what questions do you have on this last part? I'm acting like this last little bit of subbing is really easy, but maybe it's not. Maybe there's questions you have. What do you want to talk about? Subbing not going away, folks. Like, subbing's now in and here to stay. A little side skill, not a separate lesson on it. It just appears in the other lessons. I think the math textbooks think because you did y equals mx plus b, you know all about subbing, but I don't know. It might be asking a lot. So, questions here? Is good? Right. More time? Oh, that was it? I thought there was more. Isn't there more? My brain's screaming more. Did it? Yes? More? Oh, a little bit of terminology. The first is the word order. It can come up in the homework, the word order. It doesn't come up on my tests, but I just mentioned it. So if you happen to run into the word order and you're trying to do a question in the homework and you can't figure out what they mean by order, it says the exponent to which a factor in an algebraic expression is raised is called its order. So instead of saying its exponent, sometimes we say order. No good reason for that. I don't have a good reason why we would use that word. So I don't use it on tests and so on. I don't sticky with it. But again, maybe in the homework. And then family of polynomial functions. Oh yeah, let me show you some family of polynomial functions. Before I overread this, I just want to show you this thing here. Okay, so they said there's a whole bunch of polynomials. And they're all x minus 3, x plus 7, x plus 9. But different a values. What would those different functions look like? And I've got Desmos here to show you what those different functions would look like. I think I have Desmos here. Did I not load up Desmos? Desmos. There it is. Okay. And I've typed this function in. I typed in y equals x minus 3, a x minus 3, x plus 7, x plus 9. And so what you see is it's got the zeros that we would expect. Let me label them on there so you can see them. The first 0 is at 3, 0. So I can actually use Desmo to put 3, 0 on there. Oh, I'll give it a label. Oh. I'll call it a 0. Can you see that? It's good, right? Desmos is so much fun. All right, and then the next 0 is what? Negative 7, 0. Label it. Look, another 0. And then what's the last 0? Negative 9, 0. The last 0. Okay, so I've labeled those all on there. Okay, now watch. That's one version of it. I have an a value of 1. That's if there was a 1 out here, that's what this function would look like. Now notice though, there's lots of functions that go through those 3 zeros. You can have any a value you want. And watch what happens. This thing actually allows me to animate with all sorts of different a's. If I just press play, I think it's going to do random a values. Here we go. Even negative ones. Woo! Oh, it's not. It's just going up and down. It's not really randomizing them, is it? Ah, that's too bad. But anyways, you still get the idea, right? These are all part of a family of functions. They all have the same zeros. They might have different end behavior, but they all have all that in common. So do you see how they all have that really in common, those zeros? That's what they're talking about when they say a family of polynomial functions, all the ones that have the same zeros. Now, this lesson acts like a family is ones that all have the same, no, it actually says that right there. We're acting in this lesson like same zeros means all part of the same family. Family just means same characteristics. They have something really in common. And here, zeros is the easiest thing to talk about. Yeah? So a family like that. Questions there?